Hello everyone, I am Radhakrishna. This video is a part of an assignment on machine learning using Python from Skyfi Labs. The project involves predicting the houses. To accomplish this, I imported some commonly used libraries in machine learning such as NumPy, Pandas, Matplotlib, and sklearn. NumPy is used to handle multidimensional arrays and perform vectorized operations. Pandas is employed for its use, data structures, and data analysis capabilities. Matplotlib is used to draw graphs. The first step in this project involves data preprocessing. For this, I loaded the dataset and description from sklearn library that helped as reference. This dataset consists of 506 instances, and for each instance, there are 13 attributes. I stored the features from the dataset in pandas data frame and used the print function to display the data type of the features. This allowed us to view the list of columns and data contained within the features. Let's take the age column as an example. Next, I stored the target column in another data frame. By typing maximum and minimum of the target, we can observe minimum and maximum values of the house prices. After that, I concatenated the features and target into a single data frame with the target column added to the features column. I used def.describe function to get the complete description table. Moving on to the data visualization, I calculated the correlation between targets and attributes using the core function from the pandas data frame. The generated graph displays the correlation of attributes with the target variable, revealing the istat and room having the highest correlation values. Subsequently, I normalized the data. The main purpose of this normalization is to bring all the data to a common scale. Prior to normalization, the values are not on a common scale. I stored istat and targeted values in x and y variables, respectively. Min-max scaler was used for normalization to scale the values between 0 and 1, making the data easier to interpret. In the next step, I define the error function. Our objective is to minimize the error further. The data was split into the training and testing data, and the update function was used to update the weights after each example. Gradient descent was employed as an optimization algorithm to minimize the function. If the error falls between the threshold and the gradient descent process is halted and the weights are returned. I ran the gradient descent function recording the execution time using the magic function time represented as double percentiles provided by Python. Moving on to the visualization training phase, an animation was generated to illustrate how the regression line changes the course of training, shifting from the initial position to the final position. The regression line was plotted against the training dataset. I also plotted the error values across each iteration obtained from the gradient descent function. It's evident that the error value decreases with each iteration and becomes constant after a certain number of iterations. The last step is prediction. I used the testing dataset to evaluate the performance. I computed the mean square error and compared the predictor values with the target values. These values were normalized. I then plotted the predictor values against the target values, observing that the line follows the same direction in the testing data. Finally, I utilized the inverse transform function to revert the data into the original scale, effectively renormalizing the data. With this, the project on predicting Boston house prices is successfully completed. Thank you.